Hi, this is Math 1340, and this video is going to be over section 1.1, which is going to be in graphing utilities. We do a lot of graphing in 1340, and for this class, we're going to be using Desmos. So what you may want to do is go to desmos.com, click on the graphing calculator, and open it up as you follow through the video. Kind of get into how to graph in Desmos, which is much easier than using graphing calculator in many instances. Okay, so we're going to start from the very basics. And that is looking at the rectangle coordinate system. Is an XY plane. So your horizontal is your x-axis, and your vertical is your y-axis. So all y variables are measured off the vertical, all x variables are measured off the horizontal axis. The origin, which is when x is 0 and y is 0, is right there at the center. This is the origin, or in this case, letter F. And so the way we look at a ordered pair is x, y. X always comes first. So -2, 3 would be here on the graph. 4, -5 would be down here. 6, 0. 6 on your x, 0 on your y, so it's right there on the x-axis, which anytime your y is 0, you're on the x-axis. -1, -4 on here. And 0, -3 is on the y-axis. Anytime your x is 0, you're on the y-axis. So we can label these E. A is -2, 3. B, let's see. And you can do any of these points in Desmos. I won't do them all, but I'll do one. You just type in with parentheses -2, 3, and it graphs the point. We could label it A, or you can just keep off the title and keep the label, and it's just -2, 3. You can make it open. So you can change it to open, you can change it to X, you can change color, that sort of thing. Let's go back to the dot. What? So when we want to know a solution is the actual solution of a equation, we can plug in the ordered pair and it should make the statement true. So if we want to know if 3, -1 is a solution to 2x plus 4y equals 2, plug the 3 in for x, and we plug the 1 in for y, and then we have to verify that's true by getting them to equal. So 2 times 3 is 6, 4 times -1 is -4, and 6 minus 4 is 2. So it is equal. If we plug in -2, 8 into 5x minus 3y equals 15, we get -10. 5 times 2 is -10. 3 times 8 is 24, so -24. You get -39 equals 15. So what does it mean to be equal? Well, let's go back up to the first one. 3, -1. 3. We type in the equation, 2x plus 4y 2. And to be equal, we see that 3 is on the line of 2x plus 4y equals 2. It's one solution. That equation has many solutions. Every solution is the line itself. If we look at 5x minus 3y equals 15, and at point negative 2, 8, we see that that point is not on the line. Therefore, it's not a solution. We graph ordered pair. Your x is called your independent variable. Your y is your dependent variable. And there's a few ways of graphing linear equations, which is anything that has just an x and just the y. Now, Desmos, you don't have to rewrite the equation in terms of y, but when you do it by hand, sometimes that is a easy way of doing it. When you do rewrite the equation in terms of y, we'll add over the ex, 5 by 5. It gives you a setup where y is dependent on x, and that's why y is the dependent variable and x is your independent variable. Okay, now you can graph by plotting points that are true. So on here, since we are dividing by 5s, it's really makes things a lot easier if you pick things that are divisible by 5 for x. So we can pick 0 for x and 0 down here. Actually, I'm going to do it. I'm going to do it on Desmos. It'll be a lot easier that way. So one way you can do this in Desmos. Now, we haven't gotten to function notation, but you have to use it on Desmos. Do this. 4 plus 8 divided by 5 x. We can create a table x, f of x, and then we can plug in values. 0, we get 4. I'm going to turn off the graph. 0, we get 4. Plug in 5, we get 12. Negative 5, we get negative 4. If we are graphing it by hand, those would be the easiest way of graphing it because you are going to get whole numbers by doing multiples of 5, but you don't have to. We can do 1, you end up with the decimal, 2, negative 1, negative 2. You can do as many as you want. Notice though, they're all lining up. They follow the equation. That's what's used to graph these points. Okay, so you can graph these on this table. If I graph it on Desmos, I won't be graphing it on the page, but you can. But that's called graphing by points, and it's really the fail-safe method. If you're trying to figure out how to graph an equation, you don't have Desmos for whatever reason, or graphing calculator, you can graph it by hand just by counting points. So now let's look at y equals x squared minus 3x minus 4. In order to use the function notation, all you're doing is replacing f of x, which is f parentheses x parentheses in place of y. Then the Desmos would know what function to use as you insert a value for x. So that's one of the reasons we have to solve for y even with using Desmos. All right, so here we have now the quadratic. We can graph some of these points. 0, -4, 5, 6, 1, -6, 2, -6, -1, 0. Of course, there's more points graphed, and it all falls on this quadratic. So once you have it graphed, then you just connect the dots and following the equation. But when you know what the equation looks like, it makes it a lot easier to know what to graph. Right, so now let's do the next one. Negative x squared plus 5x. And we see 0, 0. What is that point? Alright, that makes sense actually. Alright, so 0, 0 is a point. 5, 0 is another point on the x-axis. 1, 4 is a point. 2, 6 is a point. -1, -6 is also a point. If the ones I didn't mention, they are on here if you zoom out. They'll follow down. But I just want to mention which ones were in line in the viewing window. Right. And so we turn on the graph and we see that points go through all those points. Okay, this is a parabola as well, or quadratic. It's upside down though. Alright, so again, you go to Desmos, you can access this, it's free to everybody. We can type in equations without solving for y. If we just want to graph it. And it graphs the line. But if we solve for y, which solve this for y, 8y equals 24 minus 3x, y equals 3 minus 3/8 x. You can type it in that way as well. You're going to see it's the same line. Just make sure you type in right. The blue line, green line match up. And then we can turn this into a function notation. Just by doing f parenthesis x parenthesis in place of your y. And that way you can actually, you don't have to necessarily use a table, but you can just type in f of 3, and it'll give you the value. Or you can create a table. Notice when you have to create a table, it always starts out x1, y1. You gotta change it to your function. That 3 gives us the value as well. There's directions here. You select the plus sign up here, create a table, and just go down to the table. And you want to change the header in the left column to x, and change the header in the right column to f of x. It goes later on when you have multiple functions. You have g of x, h of x. As long as it matches up, doesn't matter. Oops. What was I trying to change? H of x. H of 3 will give you the same answer. Same thing there. So you can change up the name. It's really all it is name. So we'll do one more. 5. It's 1.25. So we're going to use a graph to graph y equals 12 minus x squared. So you got upside down parabola. And you can scroll to increase it or get close up to it. And if we want to find the intercepts where it crosses the x-axis, you can just click on it and it'll give it to you. So that's this. And intercept here, we have negative 3.4640 and 3.464. Yeah. Now, these aren't exact answers. The exact answer would be square root of 12. These are rounded. Now, we will go through how we find exact answers for intercepts. But on a test, if it asks for exact answers, I'm not looking for you just to use decimals, but to do it by hand. But it's important to know where they are. Now, 0 to 12 is at the top. That is the exact answer because it is a whole number. And so decimals can give some exact answers, but not all. And so this is your y-intercept, which is a maximum. These are your x-intercepts. Okay, so at what points does the graph cross x and y axis? These are the intercepts. You got a point in 3.4640, 3.4640, and 0, 12. Y-intercept, x-intercepts, which the x-intercepts also called the zeros or the roots. We'll be using those terms a few times. Okay, the vertex is your highest or lowest point. In this case, your vertex is 0, 12, which just happens to be the y-intercept. It's the max point. There's no lowest point because it's a upside down parabola. And it doesn't always end up at the x-axis. If I were to do this, you can see it shifted off to the side. Okay. All right. So that's it for section 1.2. 1.1. In 1.2, we're going to look more at linear equations and rational equations. See you then.